Hello everyone, this is Maushami. Take back your time with aptdemy. We present top tips, time savers and also detailed solutions of problems. So let's begin with considering some few important problems on motion in a plane. The first problem, a projectile is projected with velocity of 25 meters per second at an angle theta with the horizontal. After t seconds, its inclination with the horizontal becomes 0. If capital R represents the horizontal range of the projectile, what will be the value of the angle of projection theta? So a wonderful problem involving some very beautiful concepts of projectile motion. So let's begin with analyzing the question. The projectile has been projected with an initial velocity of 25 meters per second. To better understand the problem, let's consider visually observing the problem. So this is the plane in which the projectile is moving, and the projectile has been projected at an angle of theta with the horizontal. The initial velocity of the projectile has been given as 25 meters per second. Now, this will be the motion of the projectile. Now, just have a look at the question. After t seconds, the inclination with the horizontal becomes 0. So, when does the inclination of the projectile become 0 degree? Now, imagine this is a point. In fact, this is the maximum height attained by the projectile. Say the maximum height is given by h. So, at this point when the projectile is there, this is the direction of motion of the projectile. Now, at this point, if you note, then the angle theta that is equal to 0 degree, since at this point the projectile is parallel to the x-axis. So it is at this point that we have a time of t seconds, that is, the projectile will reach the maximum height after t seconds at this particular point. Now, what we have here is capital R will represent the horizontal range. Now we know range is the maximum distance covered by the projectile from the point at which it was projected. So this is where basically the range of the projectile. Let us represent the range as capital R. So we need to find out the angle of projection here. So this time, the time t second, if you note from the diagram, it is nothing but the time of ascent of the projectile. As we know, the total time of flight for the projectile is given as 2u sine theta by g. So the time of ascent and the time of descent being equal, the time of ascent will be equal to u sine theta by g. So the time of ascent, this is equal to little t, which is equal to u sine theta by g. G is the acceleration due to gravity, which we can assume it to be 10 meters per second square. So this is what we have in hand. From here, we try to find out the value of u. So we'll have u equals Tg by sine theta. Now for the second part, the range capital R, the formula for the range, it's equal to u square sine 2 theta by g. So let's substitute the value of u. We have u as Tg by sine theta, but it's u square. So we'll have this as t square g square sine 2 theta by sine square theta and a g with it. Now try to cancel out the common terms, but before that let's think of how we can break up sine 2 theta. Now if you remember, sine 2 theta is nothing but 2 sine theta cos theta. So we'll substitute that here, and then one sign will get cancelled out. We are left with r equals t square g. We have a sine theta in the denominator. We have 2 cos theta left out in the numerator. So this gives us basically r as equal to 2t square g, and cos theta by sine theta is nothing but cot theta. So we have r equals 2t square g cot theta. Now if we try to find out from here, we can write 1 by cot theta this is equal to 2t square g by r. So we have cot theta, 1 by cot theta is equal to 2t square g by r. Now let's substitute the value of g as 10. We have this as 20t square by r. So this is what we have in place of cot theta, 20t square by r. So cot theta will be equal to, keeping an eye on the solution, you can see that cot theta is equal to r by 20t square. So we are very close to the answer. We have theta equals cot inverse r by 20t square. So this is the angle at which the projectile has to be projected. Now quickly moving over to the next problem. A boy. This is a problem on uniform circular motion. A boy ties a stone of 100 grams to the end of a 2-meter long string and wails it around a horizontal plane. The string can withstand the maximum tension of 80 Newton. If the maximum speed with which the stone can revolve is k by pi revolutions per minute, what will be the value of k? Assume the string to be massless and unstretchable. Okay, this is another beautiful problem that we have in hand. A boy ties a stone of 100 grams to the end of a 2-meter long string. So let's try to observe the diagram. We have a string. Sorry for the diagram. We have L equals 2 meter. This is the length of the string which is hanging from a particular support. There is a stone at the end of the string. The mass of the stone is 100 grams. Let's convert this to SI units. We have this as 0.1 kilogram. This string can withstand the maximum tension of 80 Newton. After that, the string will break off. So we have tension, not stress of course, the maximum tension in the string. T is equal to 80 Newton. So if the maximum speed with which the stone can revolve, so the speed, this stone is made to revolve in a horizontal plane such that, so the motion will be, this is nothing but centripetal motion, which means that this maximum tension which is being withstand by the string, this maximum tension will in fact provide the necessary centripetal force for the string to revolve in a circular orbit. So let's analyze that part. We have the tension T as equal to, if we recall our formulas of uniform circular motion, we have this as m omega square L. So this is the maximum tension for moving in circular motion, that is centripetal motion in fact, and from here we can find out omega. So omega square will be equal to T by ml. We have T as 80 in SI units, we have m as 0.1 and L as 2 meters. So all are in SI units now. So we can work this out. We have 0.2. So omega squared is 400 and omega will be equal to 20. Now omega, this is the angular velocity. We can relate this with the frequency. Omega is nothing but 2 pi n, n being the frequency. So you can see this, we have n equals 20 by 2 pi. That's 10 by pi. Now what's the unit? This is revolutions per second, SI units. Now, we have been given the speed in revolution per minute. So what we need to do here is change the value to minutes. That is, the time needs to be changed from seconds to minutes. So we have this as 10 by pi and second is in the denominator. So 1 second is equal to 1 by 60 minute. So this goes up and we have 600 by pi revolutions per minute. Now if we compare this with the speed that we have been given, we can very well relate and say that k, the value of k in fact, is nothing but 600 here. So this is the answer we needed to find out the value of k. So k here is equal to 600. Now take a note at the assumption. The string has been assumed to be massless and unstretchable. So this of course is very important, because if the string would have been stretchable, then there would have been a change in its length because of the weight of the stone. So these sort of assumptions need to be taken into consideration. So hope you enjoyed the video, and what are you waiting for? Get started with aptdemy. Thank you.